What happens if you're putting an antenna on sloping ground? And there's plenty of reasons why you would. Field day, you've got a property line with a bit of a slope. What happens? You can actually do a bit of a thought experiment of where are the gains, where are the losses, why it's good and why it's bad and why it's indifferent. So let's do a thought experiment. Okay, this is the easy one. This is so easy, it's untrue. Let me just put an imaginary gravity line there. So that is the real ground. Okay, and we build an antenna on that ground. Out of blue, let's say. Doesn't matter what antenna, okay? I'll model this in a minute, actually, and just show you what happens with the sloping ground. So, great so far. However, how would you do a thought experiment if the ground was sloping? So we'll put our black line there again, roughly. Hopefully I'll get it fairly equal. But this time we're going to move it around, let's say about 15 degrees. I don't know, 15 degrees is probably about that much. And we'll put our antenna, we'll put the antenna in red this time, straight off the ground, which is a bit like building an antenna that looks like that, because all we've done is just shifted it around 15 degrees. So is the signal going to be better going down the hill or not? So as part of this thought experiment, what we could do is go into our software, and I'm just building a quick vertical for the 40 meter band. And we can see on the right hand side here, it looks like this if you're interested in a 3D far field plot. That's our vertical antenna. And normally, if my mouse will keep working, if we go to 5 degrees, let's say, just some random number, 5 degrees, could be 10, but I choose 5, all my models, and then I know if one antenna is better than the other, because the long haul shortwave stuff is coming to us between about 3 and 8 degrees. It can be as high as 20, but most of the bigger DX, right, the sort of double hop stuff, 2, 3, 4, 5,000 mile plus, will be between 3 and 8 degrees. So 5 degrees of horizon is quite a good, quite a good baseline. But it's telling me here at the top middle, if I hit that button there, that is 5 minus 5.3 dBi. It's just a number, all right? Don't worry, it says minus. It could minus 5.3 bananas, minus 5.3 something, all right? So this model here is minus 5.3. Right. Okay, what happens then if we take this antenna and make it red? In other words, we'll tilt our antenna over to the right 15 degrees. Well, actually, we can do that on, I think, this one here. I don't know, X axis. Let's do the Y. It will tilt the Y. It will tilt the X axis 15. I haven't tried this. I'm hoping it's still going to be on the ground. Yeah, it is. It's over 15 degrees. So now when we do a calculate and have a look at the plot, it'll be slightly different. Not much different. I just need to check which way it's actually gone. Let me just rotate it. Hang on. Z axis. That's it. I wanted to rotate it on the X axis. Left, right. Okay, so if I now calculate it, we should see a very slight difference, that's all. There we are. We can see now, if I do my elevation at 5 degrees off horizon, that opposite the lean, so the lean is over to our right, opposite to the lean, we've got, it now says at 5 degrees, we've gone from minus 5.3 to minus 4.8 that way, and we've gone from minus 5.3 to minus 6 the other way. So in other words, you would hardly notice it. This is exactly the same as doing this, taking that blue line and make it into a red line. Now, with the magic of post-production and Adobe Premiere, I'm going to take this 5 degrees, and we are sloping which way? Right, so we need to rotate this plot around 15 degrees to the left, which will be the same as raising that dot to there. Okay, so let's just move it to the left now. It now says here that we've got 1.6 dBi, and we started off at 5.3. So that's getting on, I don't know, 7 deep. That's a lot. A 15-degree slope will give you double the power, double again, and a bit more in the direction of the slope. So, I mean, if you're trying to if you've got a property with a bit of a slope, needs to be multiple wavelengths, not just it slopes down, goes back up, and there's a blooming mountain there. I'm talking a long-term slope, for a couple of miles. Then you will have a better signal going in the direction of the slope, and I've kind of proved it to you, I hope. Next video is coming up here. I will see you on the next one. All the best. Bye for now. All right, I think we're done there. Lovely. Stop recording.